All right, let's dive right in. Today, we are pulling back the curtain on one of Python's most powerful tools, the dictionary. If you've ever needed a way to organize information that isn't just a simple numbered list, then you are absolutely in the right place. Let's get to it.
So, to kick things off, let's start with a question. We're so used to putting things in order. First, second, third, and so on. But what happens when that order just doesn't matter at all? How do you find what you're looking for then?
And that really brings us to what I call the problem of position. See, to truly get why dictionaries are such a game changer, you first have to understand the limits of other tools that are completely obsessed with sequence and order.
Yeah, exactly. With a list, everything is about its index. Item 0, item 1, item 2. And that's great when you have an ordered sequence. But a lot of the time, we don't care if something is first or last. What we really care about is how it connects to something else. We're looking for an association, not just a spot in line.
The classic phone book is the perfect real-world analogy for this. When you open a phone book, you're not looking for the 100th name in the book, right? Of course not. You're looking for Tom because you need Tom's number. The name is your lookup tool, and the number is the information you're after. They are directly linked. So, how does Python solve this? Well, it has this incredibly elegant solution called the key-value system. This is the absolute heart and soul of a dictionary, and it works exactly like that phone book we were just talking about. So, officially, a dictionary is a collection that stores values along with their own unique keys. Every single key points or maps to one specific value. So in our phone book world, the name is the key and the phone number is the value. Simple as that.
Okay, there are 3 core things you've got to remember about dictionaries. First, they are generally considered unordered, which means you can't rely on the items staying in the same sequence. Second, they're mutable. That's just a fancy way of saying you can change them on the fly, add things, remove things, whatever you need. And finally, and this is a big one, the keys have to be unique. You can't have 2 entries for Tom in the same phone book, right? Same deal here.
All right, enough theory. Let's get our hands dirty and see what this actually looks like in Python code. We're going to build our own little digital phone book, and you'll see just how intuitive this all is. So here's the basic syntax. It all starts with those curly braces. Inside, we have our key-value pairs. You see the key, Tom, which is a string, then a colon, and then its value, his phone number. Each of these pairs is just separated by a comma.
Now, what if we need to add a new contact? It is so simple. You just use square brackets with the new key, in this case, John, and you assign the value to it. That's literally it. Python does all the heavy lifting for you.
And there you have it. Our dictionary now has John in it. Now, you might notice the order looks a bit different than how we put them in. That's that unordered property we talked about. The dictionary organizes it for efficiency, not for sequence.
Okay, so what if you need to update something, like Tom gets a new number? Well, it's just as easy. The syntax is exactly the same as adding someone new. Since the key Tom already exists, Python is smart enough to know that you just want to replace the old value with this new one. That's a perfect example of what mutable means.
And now for the main event, the whole reason we use dictionaries, getting information out. If we want Harry's number, we just ask the dictionary for the value that's tied to the key, Harry. It's lightning fast and super direct.
But what happens if you try to look up a key that doesn't exist? Like what if we ask for James? Well, Python will give you a key error. That's basically its way of yelling, hey, I looked everywhere and I can't find that key. It's a super common thing, and you quickly learn how to handle it.
Okay, so beyond just adding and retrieving stuff, dictionaries come packed with a whole bunch of powerful built-in methods that let you work with your data in some really clever ways.
So here's a quick look at some of the greatest hits. .keys and .values are pretty self-explanatory. They let you grab just the keys or just the values. The .get method is a really safe way to get a value because it won't crash your program with an error if the key isn't there. And .pop is super useful when you want to remove an item but also need to use its value one last time.
Okay, you ready to level up? Because dictionaries are not just for simple things like names and numbers. A value inside a dictionary can be, well, it can be another dictionary. This is called nesting, and this is where things get really interesting.
Check out this example. We've got a player's dictionary. The keys are the player's names, but the values are whole other dictionaries that hold their stats for different game formats.
This is an awesome way to structure complex, layered data from the real world.
So how do we get to that deeply buried data? It's easy. We just chain the keys together. First, we use the key Vrat Kohli to grab his personal stats dictionary. Then, from there, we use the key ODI to zero in on the exact number we want.
And boom, there it is, 7212. It's such a clean, readable way to navigate through different layers of related information.
Okay, so let's zoom out and bring this all home. Why are dictionaries so important? Why are they such a cornerstone of Python programming? What's their unique superpower?
This table really says it all. You know, lists are ordered and changeable. Tuples are ordered but locked in place. But dictionaries? They're in a class of their own. They're mutable, they demand unique keys for lookups, and they are built from the ground up for fast, direct access, not for living in a sequence.
If you remember just one thing from all of this, let it be this sentence. Dictionaries are not about what position something is in. They are all about association. They exist to answer one question, and one question only. What is the value associated with this specific key?
And that's what I want to leave you with. Now that you've got this idea of key-value association, think about all the real-world data you could organize this way. User profiles on a website? The inventory in a video game? Settings for an application? The possibilities are literally everywhere. Thanks for tuning in.